Okay, guys, we have to now start the video. Video has begun. All right. So section 9.1. Okay. So obviously we're talking about distance and midpoint formula. They will play a very important role in understanding what happens in the next section. Like we're going to talk about parabolas, then circles, ellipses, hyperbolas. We'll use distance formula to understand why parabolas work the way they do, as well as circles and other stuff. And even we have to use midpoint too. So here are the formulas. I'm sure you've seen this before in Algebra 1 and in geometry last year. So that looks kind of crazy because you see a radical, you see 4 variables, you see subscripts, you see squares, parentheses. There's so much happening here. Here is actually what it really means. You have a point they call x1, y1. That's your first point. You have another point they call x2, y2. And then you have a segment that connects them. And that's called D. And so the way that all this is related is if you subtract the x values, you square them. Subtract the y values, square them. Add them up, square root. You will get the distance. There's actually a way you can understand how this works so you never ever have to memorize it. Do you guys know how this is derived or how this came about? Like how did someone discover this formula? What was that, Tim? What do you mean by that? Okay, so what do you mean by count? You're on the right track. So what would you draw around it?
Oh, it's a right triangle.
You want to draw a right triangle, and then what can I use to Pythagorean theorem? Is that what you're going to say, Janice? Yeah. So Pythagorean theorem is how you can actually do this. So you never have to use this as formula. There's a lot of juniors and seniors when they start doing standardized tests, and they'll ask like on the ACT or SAT, find the distance between these 2 points. Like, oh, I forgot the formula. No. Plot the points, draw a triangle, use Pythagorean theorem. That's exactly what distance formula is. So, yeah. Yeah. We're live. See that? We're live. At the end you could. All right.
Hi, everyone.
All right. Midpoint. XM, comma YM. The M obviously stands for midpoint. Will simply be this. X1 plus X2 over 2, comma Y1 plus Y2 over 2. Yeah, that's all. Because if you average the X values, so right here, that's your midpoint. So it's the average of the X values and the average of the Y values. That's it. So I think you guys know the answer to the next question. No. I will not give you these formulas. Never have, never will. Not in Algebra 2. Maybe last year, I don't know. But so, how do you go about memorizing them? So for distance formula, really simple. Let's say it's x1. That's y1. We'll say that is x2. And that's y2. And of course, that's the distance between the 2 points. Now if I draw a right triangle. So is that what you meant, Tim, by counting? Yeah, you can count the grids, but essentially what you're doing without realizing it is Pythagorean, or maybe you are realizing it is Pythagorean theorem. See, these 2 segments, the green segments, form a right angle. If you think about it, this distance can be expressed as y2 minus y1. And that could be expressed as x2 minus x1. Does it really matter how I subtract them, though? Can I do x1 minus x2 or y1 minus y2? Yeah, well, how come it doesn't matter? You're squaring, so it comes out as positive. So if you use Pythagorean theorem, a squared plus b squared equals c squared. So if we call this a, and call that b, and of course call that c, then it's very simple. x2 minus x1 squared plus y2 minus y1 squared equals d squared. And of course to get d by itself, what do you do to both sides? Square root. And you should put plus or minus on the outside, but because we're not going to say that this is a negative value, just keep the radical positive, and that's it. So essentially all it is just take the difference in the coordinates and use Pythagorean theorem. So essentially, take difference in the coordinates and use Pythagorean theorem. That's essentially all we're doing. For midpoint, which I kind of ran out of room, but okay, I can squeeze it right here. And what was that, Paul? Just the average. Just average the x coordinates and y coordinates. So that's all. Because if you think about it, what's halfway between here? xm, what's halfway between y1 and y2? ym. All right, so these examples should be pretty easy. So find the distance between -3, 5, and 4, -1. So you can do this. Subtract the x values, square them, and subtract the y values and square them. That's all. So what do you guys get when you do that? Get root 49 plus 36, which would be root what? 85. Can I pull any factors of it that are perfect squares? We check real fast. 5 and 17, but those are not, yeah, so it's not going to work. So it's root 85. Please, please, please don't do this. Some students will accidentally say, oh, well, root 49 is 7 plus 6, this is 13. You cannot square roots. Can't square it individually. So please don't do that. That's a common mistake some people make with this. And again, if you just plot the points and drew a triangle, like if you just did this really quick sketch, -3, 5's over here, 4, -1's over here. That should be pretty easy. This is going to be 6, and that's going to be 7. Same thing. You use Pythagorean theorem for that. Okay, next one, number 2. Yeah, I gotta give you a triangle first. So, let's say you have these as your coordinates. This is actually quite a cumbersome problem, and because it is, I will be okay. The 2 points program is going to be your best friend's chapter. I'll tell you right now. And Janice, you don't have that. Or do you have it? Okay, freshmen don't have it, or some people didn't have. You don't have it, Jane? Or you lost yours? Okay, I'm sorry. Okay. And you could draw it, but the thing is that you still have to calculate distances for each one, and that can just take a while. You could. You could. Well, if you graph it real quick. Yeah, and if you use like graph paper, and because obviously my graph's not going to be totally accurate.
Wait, isn't it 3 points now?
Well, you use 2 points to calculate each distance. So, distance of AB, distance of BC, and distance of AC. And so you can just use a program to work it out.
So A and B is X and Y. For 2 points.
What did I say again?
On the 2 points program, it asks for A and B.
Yeah, A and yeah. The way it works is that A and B are x1, y1. C and D are x2 and y2. But I mean, you could calculate 3 times, but it's just again, it's a very tedious process. So 2 points. So if I find AB 4, 6, 7, 3. Okay, so they say this is 4 points. Okay, I don't have a good one. I think you guys might have the one with the radicals. If I have 4.24. What's the question, Ben?
Why would we do this? Why would we find out?
Okay, I don't know what your question is. And then if we run it one more time. You also could have one that just does distance. I can give you one that just does that instead of going through the whole thing. But you should find that those are the same. So clear this is an isosceles triangle.
Oh yeah, I got
My eyeball it.
All different.
But like it doesn't have to be the one
Obtuse, you mean?
Oh yeah.
Yeah, obtuse just means you have one angle greater than 90. Which those can be isosceles too.
Yeah, but like
Scaling, yeah, actually, scaling could be obtuse or acute. Which the sides are not the same. It's not about the angles, it's all about the sides for scaling. Okay, so that should be pretty simple. Example 3, find midpoint. So -5 plus -1 over 2. 1 plus 6 over 2. So I've got 5 seconds, so should be pretty easy. What I probably should have done is I probably should give you a problem where I give you the midpoint and I give you one of the endpoints and you gotta find the other endpoint. But you can easily just work backwards and use the formula up here if that were the case. Because something plus something divided by 2 has to equal the midpoint. So you can always work backwards and figure it out. Okay, last one. Find the equation of perfect bisector. The 2 points program. 2 points reigns again. But let's do it by hand. Well, here's the thing. Just wait until we get to later in the chapter. I'm not going to ask any questions about just distance performance straight up. This is only just sort of laying the foundation for what we're doing later. Yeah. So, what was that? Yeah, I know. Anyway, but let's do this by hand. So what do we need? We need the slope. Need slope and midpoint. Because again, y equals mx plus b. And so in order to figure out what the y-intercept is, I'll need to know the midpoint, so I can plug in to find the y-intercept. And actually, it might even help to draw a graph, too. Negative 3, 4, 5, 6. And so it's pretty clear I want... Okay, that was kind of off. But that's why you need slope and midpoint. So let's find the slope first. Slope should be easy. 6 minus 4. Or 5 minus 8. How am I doing that? I'm just doing change of... What do I do up top? So change of y over change of x, right? But we need a perpendicular slope. Yep, that's right. Which is going to be what? It's negative 4. Then the midpoint, that should be easy. If you average your x values and average your y values, you should get, what was that, Tim? 1, 5. So now these two come together. Plug in negative 4 for m, 1 for x, and 5 for y. What does b equal? 9. And so your equation is simply going to be negative 4x plus 9, which kind of makes sense just looking at it. It looks like it does have a pretty steep slope that's negative. Crosses the y-axis at 9. And if you double check your calculator, okay, my program here is broken, so I can't do it. Sorry. Okay, so that's it. So we're all done.